Hello, information. So today we will start our session as early as possible. Good evening, Abhishek. Okay, so everything is okay from my side. Yes, so greeting to all the students. Welcome to Global Online, and here we are back with our course of paper 2 Commerce and Management. And in this series, if you know, we have completed many MCQs questions, okay, in the last lecture. And today we are going to do the unit that is business statistics and research, but today we are not taking the MCQs. Today we are creation, okay. And whatever I am teaching today, this is extremely oriented, is basically oriented for your examination oriented, okay. So uh, let's start. So before I will go ahead, I just quickly tell you about the global online. So what the global online in, if you register yourself for the global online, so what will you get? Okay, so you will get the daily live lectures recorded. Where it is my pen? Just give me a second. So here you will get a daily live lectures, okay. Recorded lectures is also available in your app, and complete syllabus notes in the PDF format, and also by PYQs with detailed explanation. If you register yourself for the paper 2, paper 1 is free of cost for you, okay. And our new batch will be going to be started from 19th of August, and for your convenience we will start our new batches. I will launching our new batches in every Monday, okay. WhatsApp contact number is given in your screen, so get in touch with this WhatsApp contact number. How to download the global online? Just go to Google Play Store, register with your number, then you go to my course and search the whatever the course do you want. And once you register yourself, so you can see the interface is looking like this, or here you can see that there is a unit wise folder is given to you. So do study well, okay. So here very good evening, Rudra. Okay, so let's start. I'm starting with assuming that I'm just stating the revise very fast. And the most important topic which is related, and just recall it, okay. This is for your super fast revision. This class is for you, okay. So because I saw that in the last video lectures that you have get confused while marking the MCQs, so this is just for your polishing your knowledge, okay. I know that you are a master in your subject, but just polished it little bit fast, okay. So what is correlation? Correlation, that means the most popular statistical measure that indicate and analyze the relationship between what, between the two or more variables. This is correlation. So what is the correlation is refers to, it is a technique used to measure the closeliness of the relationship between the variables. So what are the variables? That is an x variable and the y variables with normal correlation. So basically we are finding in the correlation there is a relationship existing between the variables or not, okay. And if the relationship is existing, so what a degree of relationship, okay. So there we denoted in the degree, okay. The word is degree is important when we are talking about the correlation, okay. So yes, if there is an exist in the relationship, so what a degree, what the degree of correlation, okay. Then the in which direction? So the direction, it is either your positive direction, it considered as a positive direction, or it is a negative direction, okay, okay. Then yes, if it is if there is a relationship, if there is a degree of relationship, if there is a relationship between the variables, either is a positive or negative, how weakly they are correlated, and if they are negative, so how weakly how weak the relation they have, okay. So there is these are the important points you just keep in your mind, okay. Then the next one, the methods of studying correlation. When we are talking about the correlation, there are the scattered, we study with a diagram, and we using the Karl Pearson correlation coefficient. We also use the Spearman's rank correlation and the concurrent deviation. So these are the four method in which we calculate, we study the correlation, Okay, so we will see it one by one. What is we see the see with a scattered diagram. Okay, now what is a scatter diagram? So scatter diagram is a statistical tools. Yes, variable and the independent variable. But ma'am, in the correlation there is no dependent variable and no independent variable we are studying. We are studying the dependent variable and non-independent variable in the regression. But you have to keep in your mind that is when we are studying the scatter diagram, it does not tell about the exact relationship between the two variables, but it indicate whether they are correlated or not. Just this is the dependent or independent variable, whatever the variables we have, they are correlated or not. That's it. Okay, then the relationship between these variables we can, when you are graphically represent. So this is a scattered, you can say in the diagram. Okay, if the line goes up, okay, if here you can see I'm just this is a theoretical portion, but I will tell you in this particular diagram. Okay, I'm just taking the quick revision of that, just polishing your knowledge. So here you can see the perfect positive correlation. When it will be the perfect positive correlation, you can see over here when I draw the diagram. Okay, so I diagram the all the data I have, all the data we have, all the data are plotted in the exact on the line, exactly, not they are scattered, they are not away away from the that particular line. That means it is R is, because we do know the correlation in the R. Okay, so the R, when we say the R is equals to 1 when they are going upward. Okay, the first thing that is upward from left to right. Understand? From left to right. When it goes from the left to right, so it is your positive. When it is go negative from downward, okay, the word is downward. Okay, from here you can see right to left, right to left, so it is a negative. Okay, the correlation is negative. Now when it is perfectly plotted on the line, okay, so it is perfect positive correlation. When you say the high positive correlation to a regression, not to particular, to the regression line, this line is called as no, we are talking about the correlation. Okay, so it is related to the particular line. That means when we draw the diagram. Okay, so it is also called as a regression line, but it is called as a correlation line. Okay, so so this is a correlation line. Okay, so when I am talking about this data is nearest to the particular line, nearest to the correlation line, in that case R is equals to 0.1. Okay, R is equals to 0.1 and it is a highly positive correlation. That means you can say strongly correlated. The word is also that is strongly correlated. Okay, then low degree, when you say the low positive, they are positive going to upward from left to right, but low. Okay, when you low, here you can see the data is away, how far away. Okay, far away from this particular line, this correlation line. So that means your R is near about 0.3, or you can say R is equal 0.13. Okay, if it is near about this our answer, that means R value is 0.30. That means this is a low positive. If there is a positive sign, so it is a positive correlated. If there is a negative sign, so it is negatively correlated. Now when we say that there is no correlation, when we say that there is no correlation, here you can see this particular diagram is not following any kind of direction, not an upward, not an downward, and not even it is draw a particular line. Okay, so when our data is scattered without following any pattern, okay, in that case this is a no correlation. Clear? When there is a no correlation, that means our R is equals to 0. So if they ask the question that our correlation is it will be 0, So yes, it will be 0 if there is no relationship between the two variables. Okay, there is a possibility. Okay, then what about the negatively perfectly correlation? We are starting from here. Okay, so what is a perfect negative correlation? Yes, there is a perfect relation exactly when our data is exactly on the particular line. Okay, and this draw the particular pattern like the downward. You can see this diagram is this particular line is downward from right to left, so it is a negative because it perfectly on the particular line. That's why it is a near perfectly negative correlation. When highly negative correlation is just nearest to the particular line, not exactly on the particular line, okay, correlation line, but is a nearest. Okay, so in that case 0.8. okay, minus because it is negative, and when there is an away from the particular line, so it is a minus 0.30, yes. So move ahead toward the next. That means in case of bivariant, that means where you have two. Bi means 2. Okay, so bivariant data we have to reach a single figure, because we have if we have x and y, so these are the different so you have to convert it in a single figure, okay, which will be present in a deviation in the both variable for their respective mean. For the purpose of, we use the concept of covariance. The word is covariance. Here we use the word that is covariance, combinedly how they vary. So if the data is vary, that means they are not perfectly related, or I collect the data from different sample. Okay, so in that case it is what the thing or what the concept we use, that is a covariance. So what is the formula of the covariance? There is a standard deviation is xy, because we have two x and y variables. Okay, so we are taking the standard deviation of x and y. Okay, then it's equals to 1 by n. Okay, and the sigma of n here is x I minus x of mean, then y of this is the variables. Okay, y minus y mean. So in this way you can calculate your covariance in the bivariant, if your data is bivariant. Okay, they generally they ask the question from the bivariant in the formula basis. So I just only take the formula. You have to keep in mind this formula only. Okay, the next one, that is the Pearson correlation. Okay, we have seen that is a scattered diagram. Now the Pearson correlation. So the Pearson correlation give the exact idea about what they are the variables, the extent of which they are the correlated. Okay, when the coefficient of correlation measure the intensity or degree, important word, degree of linear relationship between the two variables. And yes, it was given by the Karl Pearson, okay, in the sons of 1867 to 1936. Okay, the popular Pearson's correlation of a feature. Okay, we have the x and y are the two random variables, and correlation coefficient will be x and y is the denoted by. Now the formula is given there, different formula. In this way we can calculate our the formulas is given. In this way we calculate our r value. That means with the help of using these formulas are given by the Pearson's. Okay, so what is the formula? If we want to calculate the correlation, we have different things. Okay, the first thing is given by this one, Pearson say that we taking the summation of deviation of, I'm just writing over here. This is a short form. Okay, in the short way they calculate like this, but the longest formula that I have, look over here. So there is an x and y variables. Okay, so if the x and y variable, so how they calculate? If the suppose I'm taking the value that is 1 2 3 4 5, okay, and the y variable is 5 4 3 2 1, like this. Okay, so what we do, first thing we do that is we calculate the deviation of x. What is the deviation of x? Deviation of x, that means we considering the one assumed value from the given set of data, okay, and we just deduct the series from that particular mean. Okay, exactly we are doing with the same of dy. Okay, that means dy, then we taking the square of that. Okay, and this, in this way we calculate the summation of that, taking the total of that and summation of dx and summation of dx square. Okay, once we have complete this, how do we calculate it? I'll just quickly tell you. That is x, that means what I have assumed, suppose I have assumed this is a 3, my for the x value I assume that is a 3 is a deviation. Okay, so when we calculate the deviation from x, I minus the what I assumed. So okay, so my answer will be 1 minus 3 minus 2, 2 minus 3 minus 1, 0, then 1, 2. In this way, the same exactly we have considered the 3 over here. So this is 2, 1, okay, 0, then minus 1 and minus 2. Okay, in this way we calculate, we taking the total of that. Okay, so here d, then what we have to do, we multiply dy square, then what we have to do, we just take the dx multiply with dy. Okay, then we are taking the total of dx dy. Okay, in this way we calculated. Now let's move toward the formula. Okay, so formula of r, where the calculation of r is n into, we taking this summation of dx dy minus, we are deducting from summation dx minus summation of dy. Okay, multiplying it, then divide with taking the under root of, where we are considering first that is x variable. Okay, so n into summation of dx square minus summation of dx the whole square. Okay, then multiply with, I'm just, now we are taking the variable y, so n into summation of dy square minus summation of dy whole square. In this way we calculate our coefficient of correlation. This is the one of the formula. When this, the formula is exactly this, you can see over here, the summation of the, instead of writing dx, he write summation of xy, variable of xy. Okay, and taking the under root of summation of x square, summation of y square. This is a short form. Okay, then the another formula, when we using the standard deviation. Okay, when we using the standard deviation, so the exactly the numerator you can see, the numerator you can see in the covariance also, the numerator you can see are same. Here just they write the covariance word and the x and y, their summation of is nothing but this is same. The summation of xy, summation of xy. So don't get confused with numerator. Numerator is fixed. Now if we are taking the standard deviation, so we are considering the standard deviation of x and standard deviation of y. Okay, and in the covariance, because in the covariance we are not taking the numbers, we are just multiplying the standard deviation of x variables into y variables. So this is the, these are the formula. They ask the question from many time, that giving to you formulas and they choose the correct one or choose the false one in this way. Okay, so if you have any doubt you can ask me. Now give us questions, ma'am. Okay, I will give you, I have already take I think 4 lectures in the statistics MCQs. Okay, I have seen that the many of the students are not answering me. That's why I'm taking the quick revision of this particular unit. Okay, so today's unit is only for the your polishing your knowledge, is nothing else. Okay, so tomorrow I will take again on the MCQs on the statistics. Okay, so this is the formula. These are the also formula, but they are little bit confusing you. Okay, so I'm just remember this formula, so you can correlate this formula with this one. Okay, now the next, the value of correlation, I have already told you, that is very strong relation when your data is 0.80 to 1. Okay, and perfectly when it is only 1. Okay, and fairly strong positive when 60 to 79, and for 0.80 to 59 is moderately positive, and if your data is 0.20 to 0.39, so it is a weak positive. And when it will be very weak, when it is 0. There is no correlation, and if you see there is a near about 0.19, so it is very weak. Exactly it is for the negative one. Okay, Now the next step, what is the probable error? So what is the probable error? Probable error is calculated or usually taken the place from the sample. Probable error is happen when we, because the reason for probable error or reason for Karl Pearson correlation, rank correlation, Karl Pearson coefficient is a, no, Chandan Kumar, Karl Pearson coefficient is a different and Spearman's correlation is a different. These are the, we are taking this, look over here, the Spearman correlation. They both are different. They both are different. Okay. So look over here, why the probable error happen. The simple thing, whenever we collect the data, whenever we take the data, we do not take whole population. From the whole population we take a sample and we consider that this particular sample will denote the whole population. So isn't it true, if I am specifying that if I have a data of the particular, suppose this is India, okay, and I have to find out how many females or the madam, how can I improve the score in statistics, or were on the question, were out of box. How do you score it? You have to work on your basic concept. This is the most important thing. If your basic concept is clear, so you can easily, because whatever I have seen in the previous year question paper, so it not in the advanced level. If your basic is ground to your basic concept, your root is clear, so you can easily score in the business statistics. So what you have to do, just read it as much as possible. Okay. So if you have any doubt, if you are demanding for that you have to just, ma'am, take the in the detail all the lectures of the statistics, so I will be there for you. Okay. Okay, let's come to the point, that is there is an example. I'm giving the example that if I'm taking the research of that in the particular area, how many are the cancer patients. Okay, so is it difficult for me to study the whole India? Okay, so what I'm going to do, I'm taking the particular sample. That means I'm choosing particularly a Maharashtra. Okay, just think of that, particularly Maharashtra, that yes, this Maharashtra is Maharashtra or the Karnataka, whatever the state, okay, consider. So I've state a particular state, and I've found a particular state. When I do this the statistical analysis, and I consider that whole India is exactly in the suppose 20% of the patient are from the Maharashtra, suppose. Okay, this is a just example, okay. So if the 20% of the population of the Maharashtra is the cancer patient, so can I conclude that all the other 20% of all are from the India? No, no, this is not exactly that's I saying, if it is difficult for us to it's difficult for us to consider all the population. Okay, so what we are assuming that it is, okay, so that's why the probable is usually taken place from the sample. Exactly this question I have asked in the yesterday's lecture. If you haven't seen, just go there and look. Okay, so here that from the sample, because there is an error of the possibility of coming error, because you're using the sample. If I'm taking the population, there is a very less chance of the there is a less chance of the probable error. Okay, these samples are in pairs. The pairs generally come from the very large population. Okay, so the probable error correlation help in determine the accuracy and the reliability. Why we calculate the probable error? Because the probable error, whatever the percentage is calculated by calculating the probable error, it shows 99.99% data is accurate, na? So exactly probable error is do is determine the accuracy and the reliability. The value of coefficient has so far depend on the random sampling is used to determine the determination of the Karl Pearson correlation. Yes. Then according to the Horace secrets, the probable error of the correlation is an the amount which is added and subtracted. That means what we doing in the if my data is 0.99, suppose. Okay, so what is a probable error? There is a probable error, that means my data is going to be 0.01%. There is a probability. Okay, there is an error, and minus 0.0%. That means there is a positive way also, and there is a negative way also. Like this, that means the correlation coefficient limit within which the chance are even, that coefficient of correlation from the series selected at a random with false. Okay, so this is a limit. What is it? This is the range. This is a limit within which there is a chance even that correlation, that means my R, okay, correlation coefficient from the series selected at a random will fall. Okay, that is on the random basis. Clear? Now the next one, this is a formula of the probable error. What is the formula of the probable error? 0.6745 multiplied by 1 minus r square divided by under root of n. This is the formula of the probable error. And what is the standard error? Standard error is used to for is the formula of formula is this one. This is the formula of the standard of 1 minus r square divided by under root of n. Now what is standard error? Standard is basically standard deviation of any mean. Okay, the standard is generally used to refer the any sorts of the estimates belonging to the standard deviation. Is there is any mistake? Again, hello. Problem from my side, Chandan Kumar? Okay, so why we calculate the standard error? Because there is a when we calculate the regression, we use the standard deviation. So there is a probability that there is an error in the standard deviation. So to finding out this error, we use the standard error. And how do we calculate it? With the formula of 1 minus r square, because r square, whatever the value we have calculated in the r, divided with the nth unit. N means the numbers of, okay, number, that means here you can see there are the number n is equals to 5. There is a 1, 2, 3, 4, 5. So this is 5, the under root of nth. Okay. So in this way you calculate your standard deviation, standard error. And why we calculate the standard error? For what? To estimate belongs to the standard deviation. Is the 0.674 of the standard error. Okay, what is probable error? Probable error is your 0.674 of standard error. Okay, so let's either they can ask you this kind of question in the formula form, either they can ask in the theoretical form, in the statement format. So if you are clear with this concept, you can easily mark your question. Okay, now Spearman's rank correlation. First thing, just keep in your mind, when I'm talking about the Karl Pearson, okay, and when I'm talking about the Spearman rank correlation, in the Karl Pearson of that, and we are taking the summation of that. When I'm talking about the Spearman correlation, whatever the data I have, what I'm doing, I'm giving the rank to them. Whatever the highest value, I am giving the rank to them as a 1, giving the rank. Okay, then I have the next lowest one, that is 4. So this is 2, then this is 3rd, this is 4. I am giving the rank to every data. So this is the Spearman rank correlation. Karl Pearson correlation and the Spearman's correlations are totally different. They both are different. Okay, now what is a Spearman's correlation? So this method is computing the correlation between two characteristics. Okay, in this method the various items are assigned rank according to the two characteristic correlation computing between these rank using rank. That means what I am doing over here, I have this data, I'm giving them a rank. Okay, the first one, second one, third one, like this. Okay, so the Pearson correlation represent by the P or RS, that means rank Spearman. Okay, RS, Spearman's correlation, R1. Okay, yes, then it's non-parametric measure of the strength and direction associated with the existing between two ranked variable. The word is rank is using everywhere. Okay, so it is a non-parametric measure of the strength direction of association. Okay, then it is determine the degree to which the relation is monotonic. Okay, now what is the monotonic? What is the monotonic? So monotonic, over here you can see over here, monotonic means there's following some pattern. Okay, you can easily you are able to give easily rank to them. This is, you can see, this is downward and this is monotonic. Here you can, this is upward, this is monotonic. Here is no non-monotonic. That means you're not following some kind of pattern. Okay, the Spearman's correlation one result when the two variables being compared or monotonically related, even if there is a relation is not linear. If they, here you can see there is a no linearity, but still they having a relation. It means that all the data point are greater x value that of the given data point will having the greater y value as well. The contrast, it doesn't give the perfect Pearson's correlation. Okay, so the formula is important. That is, the formula is RS. Okay, you denote it in the RS, 1 minus 6 multiply with summation of deviation of 2. Okay, divided with n, and in the bracket we are taking we are deducting the 1 from the n square. Okay, in this formula where n is a number of data, yes, the point of the variables, and the D2, this is D2. Okay, D2 is a difference in the rank element. Now if I have, let's understand this, if I have x and y variables 1 2 3 4 5 and 5 4 3 2 1, so we are giving the rank to both of them. I have the example. Yes, I have it. Okay, we will see in this question. Let's understand over here. This is the example. Rank correlation, marks in the statistics is given and marks in commerce is given to you. Okay, so we are considering statistics is a x variable and the marks in the commerce is a y, already is given over here. So I'm giving the rank to rank, who score the maximum, I give you him a rank, who score the lowest one. Okay, so either you will start with the highest one or either you will start with the lowest one. But in this question he marked the answer as a lowest one. So 35 is the lowest one, so he marked the x1. Okay, then in the y you can see the lowest one is 13. So he marked 30 as a first rank. Okay, and what is it then, the highest is 95, so 95 is a 10th. Okay, so highest number is n is equals to how many numbers we have, 1 2 3 4 5 6 7 8 9 10. So n is 10. Here is also n is equals to, so 10. So in this way what you have to what you did over here, that means the lowest one giving the rank 1. Okay, next lowest one, next highest, that is your 40. So 40 is 2, then 45 is 3, give the rank 3, then 54. Okay, so in this way you have, first you have to give the rank. Once you give the rank, you take a difference of x and y. What is the difference between the rank 1 in the statistics and the in the y? Okay, so in the commerce. Okay, so we're taking the difference from the x we could deduct the y, so it is minus 1, 1 minus 3 minus 2. Okay, so in this way we have calculated this, that means we have d, and after that we're taking the square of that. Okay, so 2 square 4, 2 square 4, 0 square 1, like this, or we're taking the summation of that, so that is a 16. So what is the formula? 1 minus 6 multiplied by summation of d square, okay, divided with n. Okay, so what is 1 minus 6 is multiplied, 16 is our answer. So I have wrote the 16 over here. Then this is 10, the 10th root 100 minus 1, so it is 99 multiplied by with 10, this is 99. Okay, and this is, so 99 multiplied by, so when we calculate is 0.903, this is the answer, the way you have calculate the correlation, rank correlation. Okay, so in this way you have the rank they many time they ask this kind of question in your question paper. I have seen in the previous question paper. Okay, so in this way you have to calculate the rank correlation value. Okay, now the next one, non-concurrent deviation. So what is a non-concurrent deviation? This is another simple method of obtaining the quick but crude idea of the correlation between the two variables. This method only direction of change in the concerned variable are noted by the comparing the value from its preceding value. Okay, if the value is greater than the preceding value, that means I'm just look over here. This is a formula. Again, I'm explaining in the with an example, so it will be easier to understand. Look over here, the roll numbers are given to you in the question, in the particular this example. Roll number is given 1 2 3 4 5 6 11. Okay, the marks in the macro in economics and marks in the macroeconomics, these marks is given to you. Now let's arrange this. How do you arrange this? In the exactly the way they are giving, 80 45 55 56, like this. Okay, so you just mark it over here, you just write over here. Okay, like this. Now what the next thing you have to, there is no calculation. This concurrent formula, this concurrent method is not about the calculation here. Just you have to take either it is positive or either it is negative. Okay, so what you have to do, see, that is first the roll number first got 80 marks. Okay, then roll number second get 45 marks. So here you can see the preceding number is less than the previous number. Clear? So that's why when we are taking the D1, okay, so D1 is negative because first roll number got a 80 marks and second roll number get a 45 marks. So that's why here I use a minus mark. Okay, negative marking. Okay, then the third roll number get a more mark as compared to the second roll number, so this is a positive sign. Then if our preceding exactly where it is, oh you know, look over here, if the value is greater than the preceding value, it indicate in plus sign. If the value is less is indicated by the, if the less, so it is indicated by the minus sign. Is equals indicate by the equal sign. Okay, so because our preceding value is greater than the previous value, so I mark the plus sign. Then preceding value is greater than the previous value, so I mark plus sign. So here you can see every value is preceding value is greater than the previous one, so that's why all the signs is positive over here. Okay, exactly we are doing with the same with our marks in the macroeconomics. So first roll number got 82, another roll number, the second roll number got 56, so there is a negative sign. Okay, then again 50 is less than the 56, so it is my negative sign. 48 is less than the 50, so negative. 60 is more than the 48, that's why positive. 62 is greater than the 62 is greater than the 60, so it's positive. So where you can see everything is in the ascending order from this point of time, okay. So everything which is increasing in the ascending order, so they having the positive sign, we mark positive sign. Now the next thing what you have to do, the concurrence. Okay, so concurrence, how do you, minus minus plus. Okay, then my plus minus minus. Okay, so this is disagreement. Concurrence means this is a concurrent, that means if they have create a positive sign, okay, so it is a concurrence. Okay, and disagree when they are both are different, both are, that means negative sign. So plus minus minus, okay, then the plus minus minus, then the plus plus plus, okay, plus 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 plus, in this way. Okay, so how many plus we have? 1 2 3 4 5 6 7 8. Okay, so the 8, and the how many disagreement we have? That means 2. Okay, so what we have to do in the next, that means hence the C, let's understand with this, where it is. Okay, so equal sign, the design the concurrence, the number of such concurrence is denoted by the C is concurrence. Similarly, the remaining pairs are marked with minus sign, is another column. D, that is designated as a disagreement, we have seen. Okay, so this is a formula. This is the most important thing, which you have to keep in your mind, that is RC is equals to plus minus under root of plus minus 2 concurrence minus M. Okay, now what is the M? Look over here, let's understand this formula. Okay, so here the C concurrence is 8 and number of pair of the deviation is 10. How many total we have? That is 10 we have, na, total number. D is equals to 10 we have. Okay, then the formula is 2C, that means 2C is, what is your C is concurrence, that is 8 is R, so that means 2 multiplied by 8 is 16, and D is your D, either you write it D or either you have write the M. Okay, so you can D or you can say M is nothing but your number. What is? Numbers. Okay, so D is a number of pair of deviation. Okay, now so here D is 10. Okay, 10 10. So when we calculate 0.60, what which is a positive. Okay, so how it will be the positive? RC is equals to, taking the under root of 0.6 is equals to 0.77. So in this way you calculate your concurrent in the your R with the concurrent method. Okay, then the regression. Okay, we are I have, okay, only 10 minutes. We'll continue, then we will 10 minutes 16. Okay, I'm just ending over here. 6:30 to 7:30. Am I continued or end? No, I have time. No, I have 10 minutes more. Okay, let's understand with the concept of regression analysis. So the regression is describing the dependent variable. The regression where we are thinking about regression. This is a dependent variable and the independent variable. Okay. So independent variable regression analysis measure the average relationship between the dependent variable and independent variable. Just keep in your mind when we are talking about the regression. So the most important example you have to keep in your mind, that is a father and the son. So father is an independent variable and the son is dependent variable. Okay, there are the two types of variable in the regression, that is dependent and very independent. The variable is used to predict, also called as a independent. Okay, the variable which used to predict, that means we use for the prediction. Okay, so this is an independent variable, and the variables or the regressor or the predictor or explanatory variable. This is your explanatory independent variable is also called as a regressor variable. Regressor is also called as a predictor, is also called as a exploratory variable. Okay, then the variable whose value is predicted by the independent variable is dependent variable. Okay, when we use it, the whose value is predicted is a independent variable. Okay, then regression line. Regression line means what? This is the way you have calculated the regression line. Regression line is a line that best fit to the data, is also known as a line of the base fit. Okay, the degree to which the variable are correlated to each other. okay, depend on the regression line. Estimation can do good if the regression line fit the data analysis. Okay, so here let's understand the regression line in the this is in a simple way. Okay, how do we calculate what is a regression line? This is a regression line. Okay, so if what is regression line? X is equals to a, okay, plus by. Okay, so here you can see this is your predictor, what you want to predict. Okay, and what is b? What is about the a? This is a, intercept a, this is a, so this is intercept, that means where the estimate of the regression line, and this is b is your estimated regression slope, where this is slope, it is negatively slope or it is a positively slope. Okay, so most of the time they ask from this, they give you the formula and they ask what is the slope, what in this formula is slope. So the slope, just keep in your mind, slope is all, it's connected with your dependent variable. Okay, it's connected with dependent variable, and which is connected with your dependent variable, this is your slope. Okay, and intercept is a, when you have add with this one. Okay, this is now the properties of the regression coefficient, the geometric mean regression coefficient. The formula of calculating the regression is r is equals to under root of plus or minus, either it is bxy multiply with byx. So now what is bxy? Bxy, that means x correlation coefficient is arithmetic mean of the two regression coefficient. Arithmetic. I'm not getting your question, Chandan Kumar. Correlation coefficient is arithmetic mean of two regression line. Okay, so look over here, that means bxy means x on y, that means x is dependent variable and y is independent variable. When I'm talking about the byx, so y on x, so here y is dependent variable and x is independent variable. So we have to calculate in the both way, true or false. Okay, so here the geometric mean regression coefficient is a regression coefficient of x on y and regression coefficient of y on x. Okay, so geometric mean of bxy and byx is a is the correlation coefficient. Okay, so here no, exactly, the geometric mean you have called the arithmetic mean, not, it is a geometric mean. The correlation coefficient is geometric mean of the two regression line. Because why we use a geometric mean this word? Because we are using over here the under root, the same sign. If byx are a positive, then use a positive sign otherwise. So let's understand over here that if our byx and bxy is this is positive, this is positive, then our r is positive. Okay, if this is negative, this is negative, so understand this more thing, that is if the one regression coefficient is greater than the than 1, then other must be less than 1. Okay, if one of the value, that means if bxy is greater than 1, so another byx is must be less than 1. Okay, this is also the one of the property of the regression coefficient. Okay, and the most important thing, that is if when I calculate my regression value sign is plus, so the correlation value is also plus, that they carry a same sign. If my correlation is positive, my regression is also positive. If my correlation is negative, so my regression is also negative. Okay, Understand? Anything else? I'm just reading this as quickly as possible. Okay, just already I have explained you, but if I'm forget some points, so it will cover over here. The line of regression, we have two regression line. Okay, x on y and a y on x. On the basis of x on y, we calculate a bxy, and on dependent variable of y for given the independent variable of x. That exactly, that means if I'm taking the x y on x, okay, so here is y is dependent, okay, and x is independent. Okay, then if the x is considered the dependent variable, y is independent and x is dependent. So when I'm talking about the x on y, okay, so here x is dependent and y is independent. Exactly. Now the important to know that regression line x on y on x and x on y are different. Okay, these line cannot be interchanged. Okay, you cannot interchange. This is an important thing, that is the regression line, that is x on y, either it is change. Okay, the regression line y on x cannot be used to predict the independent variable. Okay, because we are not using the regression line, y on x cannot use to predict the independent variable. We just think that you have to keep, that is independent variable are independent. We do not predict the independent variable. We are here to predict the dependent variable. If they are the wordings are important, okay, don't get confused with this word. Okay, so here we are using a regression line to predict the dependent variable, not a independent variable. So this word is cannot use to predict the independent variable. Okay, so this is, okay, this is the equation which I am talking about. Y is equals to a plus bx. So a is intercept. Okay, this is the intercept. Okay, so this is the intercept. Okay, and b is slope. Okay, b is slope, and slope is always and always along with your dependent variable. Okay, dependent variable. Clear? Okay, so we have completed over here. Okay, so see you soon. See you in the next lecture tomorrow, and within some more questions, okay, of statistics. You tell me, I'm taking the more questions related to statistics, or I have to choose another. Okay, so then bye. I'm choosing. You have to. Thank you everyone. Okay, so bye bye. Take care. Do study very well. Okay, and I will be there for you for any time. Okay, so you make yourself comfortable to ask me any question. Okay, so bye bye.